Let's look at these graphs. In this graph, it's representing bracelet sales. For every bracelets that's sold, you earn $10. So if you sell 0 bracelets, you're going to make $0. Next, if you sell 1 bracelet, you get $10. At 2, you make $20. At 3, $30. At 4, you make $40. Oops. 5, you make $50. And we see the pattern will continue. So it's going to increase by $10 for each bracelet sold. In the next example, we're talking about the volume of water that's in the tub. For each minute, half a liter of water is poured in. So after 1 minute, we have half a liter. At a minute, at 2 minutes, we should have 1 liter. And you see this is continuing. So 3 minutes, 1.5. As we go on 4 minutes, we have 2 liters. 5 minutes, we have 2.5. 6, we're at 3 liters. 7, 3.5, and it keeps going per minute at a half liter increase. Let's look at the road trip. Your car is traveling at 100 kilometers an hour. So each hour, we are going to increase 100 kilometers. Of course, if you've driven 0 hours, you have traveled 0 kilometers. At 1 hour, you have traveled 100. At 2 hours, you've traveled 200 kilometers. 3 hours, 300. 4, 400. 5 hours, 500, and so on. The cost of parking at the Hamilton Airport. It costs $40 a week to park at the airport. Of course, if you've parked for 0 weeks, you are paying $0. After a week, you are paying $40. If you park there for 2 weeks, we have an $80 bill. 3 weeks, you're paying $120. 4 weeks, $160. 5 weeks, $200. And we're going to increase by $40, and we can add that on to find out the number of weeks. Now, what we've just seen in all of those examples is a direct variation. So we say that the variables are in direct variation if they're increasing at a constant rate. Now, when we say a constant rate of change, we could also call that a variation constant. Same idea. And when we have something that is increasing at a constant rate and it's a direct variation, the other thing that happens is the graph passes through 0, 0. Because as all of the examples showed, that if I had here 0 weeks of parking, I am paying $0. If I've traveled 0 hours, I have gone 0 kilometers. I haven't turned on the tap. There are 0 liters of water. And the bracelet sale, if I've sold 0 bracelets, I've made $0. So this is a direct variation. Graph always passes through 0, 0. We have a variation constant. Sometimes you'll hear it called the constant of proportionality. Fancy words, but really all it's saying is every time that we're increasing, it's increasing by or decreasing at the same rate. So we use a fancy symbol. We could say y is directly proportional to x. This Greek letter is alpha, and alpha shows that this is a relation. So y is directly proportional to x. Now, if we were to use an equation, the equation to represent a direct variation is y is equal to kx. Now, the letter k could also be represented by other letters, but right now the k is just a placeholder to represent the rate. So remember, we had y is equal to 10x for our bracelet sale. We had y is equal to half x for our tub and water volume. We had y is equal to 100x for our road trip. And we had y is equal to 40x for our airport parking. So the k is the rate of change, 10, half, 100, and 40. So the k here, the rate at which things are changing. You probably remember this from when we did ratios, but we can always find the rate. Now, what's the rate for the price of broccoli? We have $5 for 3 broccolis. Now we have 2 units going on here, and we're going to rewrite it. So we have $5 over 3 broccolis. So when we simplify that, we would get $1.67, and I've rounded that, per broccoli. Our second example, 150 calories per 2 cookies. The rate, we need to find the unit rate, which would be for 1 cookie. So we're going to put it into our fraction, 150 calories for 2 cookies. So for 1 cookie, we would have 75 calories per cookie. You run 32 minutes for 5 kilometers. What's your rate? Let's put it into our fraction as well. 32 minutes per 5 kilometers. Put it into our calculator, 32 divided by 5. So it would take 6.4 minutes per kilometer. For $11.32 for 8 croissants. So let's put that into our calculator. 11.32 divided by 8. We have $1.42. Let's round it. So $1.42 per croissant. Lastly, $91.20 for 60 liters of fuel. Let's find the rate at which this is changing. $91.20 divided by 60 liters, 91.2 divided by 60, and we have 1.52 per liter. Now you'll notice that for all of these variation constants that we've looked at, they all have two different variables. In the first one, I'm looking at money and broccoli. The second one, I'm looking at calories and cookies. Third one, I've got minutes and kilometers. I've got amount or price and croissant. And here I've got amount per liter. Now let's interpret these graphs again. We've got the cost of printing t-shirts. Now this one, a lot of places where you print t-shirts, you might have to pay a flat rate for them to even consider taking your order. They have to set up their machines to print your design, and that would be a flat rate here of 150. For each additional t-shirt, they're going to charge $10. So even if I purchased 0 t-shirts, the fact that I've brought them an order and I decided to cancel at the end, I still have to pay 150. Now, if I bought 100 shirts, I would be paying 1,150. If I bought 50 shirts, I would have paid $650. Okay, filling an aquarium. Once again, the same aquarium example that we did yesterday. I've only removed some of the water. So even before I start filling, there is already 380 liters of water in the tank. For each additional minute, there is 4 liters of water that's going in. So after 10 minutes, I have 460 liters because for each minute, we went up by 4. Now, a partial variation, once again, also has two variables that are related to each other by a rate of change, but the difference is none of these go through the origin. They all start somewhere else. So it's partially related because even if I didn't deal with the rate of change, I still have to start at a value that's greater than 0. So a partial variation is very similar to a direct variation, except that it doesn't pass through 0, 0. So when I have a partial variation, my equation, instead of just kx, I'm going to add some sort of base or an original value. Now the base, we had a base rate or we had a base volume that we started out with, and so we have to add it to the base. Kx, same, this is the direct variation. So we have our rate and we're multiplying it with our x value. Let's pause the video. I want you to try some of these questions on your own. Find the variation constant for each of the following. Identify the relationship as either direct or partial. And then in these equations, I want you to identify the relation as either a direct variation or a partial variation. Creating an equation. Now, remember when we talked about um, the scenario where we printed t-shirts? It costs $150 to set up the machine and $10 for each printed shirt. Is this a direct or partial variation? Well, there's two things going on here. We've got the rate, we've got a base fee, so we know that it won't go through 0, 0. That means this is going to be a partial variation. What's the rate here? The rate, $10 per printed shirt. What's the base? We have a base fee of $150. Now, the rate will always tell you about the variable. So in the in the rate, we have $10 per shirt. So that gives us the clue that the variables that we have is going to be cost, which is in dollars, and the second rate, shirts, number of shirts sold or printed. Which one is X and Y? Well, Y is always our dependent variable. So it's always going to be the first one in the rate. Y is the cost because the cost will always depend on how many shirts were printed. So let's define what X and Y are. Let Y be the total cost, and the cost is in dollars. We have X. Let X be the number of shirts printed. So let's write an algebraic equation to model the situation. Y is equal to mx plus b. We're going to use m to represent the rate of change and b to represent the base. So since I know that our rate of change is 10, I'm going to substitute 10 into the m, and the base fee is 150. I'm going to substitute that in the b. So our equation y is equal to 10x plus 150. How much would it cost if 30 t-shirts were ordered? Now, if 30 t-shirts were ordered, we know that the x represents the number of t-shirts printed. We would have an x value of 30. So let's substitute that into our equation. 10 times 30 plus our base rate of 150, it would cost us a total of $450. Right, another set of questions here. Is this a direct or partial variation? Write an equation to model it. Now we're going to do the same thing that we did here. Identify the rate, identify the base, identify the variables, and then substitute it into our equation that has to be y is equal to mx plus b. And of course, if there is no base, we just ignore the b. So we have a taxi driver charges $3.25 plus 25 cents per kilometer. Now, 325, this is the base. The fact that you've called the taxi driver, you have to pay $3.25. Next, our rate is 25 cents per kilometers. So because we've got a rate and we've got a base, we know that this is a partial variation, and we are going to use the equation y is equal to mx plus b. So let's substitute the values that we have. We know that m is our rate of change 0.25. B is going to be our base of $3.25. So 0.25x plus $3.25. Now, of course, since we wrote with an x and a y, we need to define what the x and the y is. So we're going to say where x is, and we refer to our rate, is the number of kilometers, and y is total cost. Example 2. David cuts grass. He charges $12 per lawn. $12 per lawn. Once we see the word per, we know that we've got a rate. $12 per lawn. Is there a base fee? Nope. He's just going to show up, and if he cuts your lawn, he's charging you $12. So because there is no base, we know that this is a direct variation. And our equation y is equal to mx plus b, we're going to substitute it in. Y is equal to 12x plus 0. Now, because it's plus 0, that's kind of silly for me to write it. So I'm going to just write y is equal to 12x. What do they represent? X, let's go back to our rate, lawns, per lawn. So we have where X is the number of lawns cut and Y is the amount of money. So the cost represented in dollars. Okay, we have a cup of coffee costs $1.79. Is this a direct or partial variation? Let's identify this. $1.75 per cup of coffee. So that's our rate. $1.79 per coffee. We've got no base. This is a direct variation. I'm going to use the equation y is equal to mx, and I know that b is going to be 0. So really, I don't have to write the b. Y is equal to $1.79 times x. What are our variables? We have x is the number of coffees purchased, and y is the cost in dollars. Right, last example here. A submarine rises from the depth of 5,000 meters to the surface at a rate of 10 meters per minute. Now, here's a hint, because the submarine is 5,000 meters below sea level, we need to consider this as negative 5,000. Okay, so we have our rate. It even told us that the rate is 10 meters per minute. So our rate, 10 meters per minute. Where is it starting? This is our base. Base is negative 5,000. Let's substitute this into our equation. We know that this is a partial variation, so we're going to use our whole equation, y is equal to mx plus b. Y is equal to 10x plus negative 5,000. So if I have a plus and minus, we have subtract 5,000, where x is the number of minutes and where Y is the meters. Now try this on your own. We have a furnace repair company charges $68 for a home visit and an additional $50 per hour if repairs are needed. These are some questions for you to try on your own. These are not examples, but rather homework. Just to give you a heads up, when I have a commission, this means I have 15% on the total number of sales. Now remember, if I have 15% of the sales, I'm going to do 0.15 times the sales. More homework questions for you to try, and that's it.